Record. Good morning, guys. Let's continue. So yesterday we talked about a new package called as Pandas, and as I mentioned earlier, Pandas is a kind of Excel on steroid, or you can say Excel for Python. So whatever operations you perform on Excel, you can easily perform them using a Pandas package. And this is something we started yesterday. If you can recall, we used a simple data type called as series, which is again provided by Pandas, and we created one-dimensional array. Now today we have to move further, and today we have to see what can be done with that series. How can we combine those series objects together, create something called as data frame, and how we can perform the operations on the data frame. So this is something that we are going to explore today. You can log into student portal, you can look at the code sharing utility, you can start copying the code along with me and see if you can get the things and see if you can understand the things. So that's a little bit different than what we have seen last time. So let us continue with this further. Let me create a new page as usual. That's page 1. So this is where we are going to create a simple series to start with. We'll see a few advantages of series, and then we'll combine them together into something called as a data frame. Again, to do this, we need pandas. So import pandas as PD, like I said earlier. If you want, you can go for NumPy as well. Importing NumPy is not mandatory, but more or less time, whenever you are working with application like pandas or application like machine learning, there you generally will need that NumPy. So it's a good time to import that NumPy. So whenever you need it, you can simply use that. Let me start with the def function 1. This is where I want to create a simple series object. Now, if you can recall, we talked about a series being a one-dimensional array. So this is a one-dimensional array based on NP array. So whatever we have seen last time regarding that NP array, it still holds true here. Okay, so let us continue here and say I want to create a series object. To create a series object, I can say pd.series, and you can pass the collection which you want to create a series with. I want to create a series with, let's say 10, 20, 30, 40, 50, as simple as that. Just to start with it, again, I want to print that S1 object and want to just confirm that this is nothing but a series object. So basically, this is a kind of a confirmation that we are dealing with a series object. Let me call that function and let us start from there. So in this case, if you pay attention, we are using a series object, and series always contain two things. One is called as index and the other one is called as values. We already separated them yesterday, and probably if you can recall, we said something like this: print index, which is equals to s1 dot index, and if you want to separate values from that, you can say values is equals to s1 dot values. That's it. So this is the way we can separate the index and values in order to see what index values are available and what values we are storing on top of those index. It seems like index we are starting from 0 to 5. 5 is not included. You see, it ends at 4. And the values we are storing are like 1, 2, 3, 4, 5. So there are 10 to 50 values, and that's absolutely right. So these are the values we stored on those particular index values. Fine. So let me continue further and let us do some operations on top of it. So this is going to be my function 2. I want to create that series object one more time, and we want to perform few operations. Now the operations we already have performed earlier. One of them is called as indexing. So hopefully you can recall. Second one is something called as a filtering. Now hopefully you still can recall that as well. Indexing, filtering, we already have done that last time. Indexing is nothing but indexing is nothing but just getting the values on a particular index value. So probably I want to come back here and say value at 0th position is equals to s1 of 0. Nothing different than what we have seen last time. You can also go back here and get the last value like index of 4 or s1 of 4, and I can get the value right there. So let me call that function 2 and get the index values like 0 to 4. Now, if I want to go for the negative indexing, this is the positive index because we are using the positive values. So positive indexing, and this is kind of negative indexing. Negative indexing is supported by Python. So basically, if I say value of give me the value at -1 position, unfortunately, in this case, it is not going to work. I hope you can recall the fact that here we are not using the index which are generated automatically. Here we are using the index starting from 0 to 1 or 0 to 4 precisely. And those are the indexes possible for you. You can't use other than them. You can't use directly -1, you can't use -4, nothing like that. If it is a list, it would work. If it is an NP-array, it would work. But this is a series, and that's the reason why negative indexing are not supported. So negative indexing is not supported because the values does not exist here. I mean, the value which we are trying to get from the index position -1 does not exist, because -1 does not exist in the index values. So if I really want to check this out, see here. So if I come back and say how many index positions are available. So if I say s1.index, you will see that the index starts from 0 to -1, 0 to 4, and that does not include -1. That's the reason why we are not able to find the -1 there. So this is not possible if you do not have the index value which we are trying to use here. So -1 does not exist. That's the reason why you can't use -1. So you are pretty much kind of limited here. Whatever index values are present, those only you can get them. Now, regarding filtering, I hope you can recall, we already have seen this last time on NP-array. Now, what do you mean by filtering? Filtering is like we want to get the values, let's say greater than 30, for example. So how do you do that? You can come back here and say, maybe I'll try to say values, or maybe directly say S1 greater than 30. Let us see what does it give me back. So probably if I say S1 of 30, if you can recall NP-array, you easily can see that it is giving me false, false, true, true. In a sense, it's kind of giving me a one more series object which is having true, false, true, false, true, false, depending on the criteria you are adding here. So the criteria here is S1 is greater than 30. This is same logic we already have seen in NP-array. Is 10 greater than 30? Is 20 greater than 30? Is 30 greater than 30? 40 greater than 30? 50 greater than 30? Whatever the answer here is, that will be added into one series object, and the series object will get written here. Now, because this is a series object, and because I'm getting the true, false, true, false, true, false, like what we have seen earlier, we can easily go back here and say, hey, give me the values greater than 30. Now, all we have to say here is just say S1 of S1 greater than 30. Now, hopefully, if you can recall NumPy, a NumPy array, you see that it is exactly working like it. So probably values greater than 30, there are two values, 40 and 50. Notice it here. We are not getting an array. We are getting again a series object. So whenever you are performing a filtering operation on series, you always will get a series out of it. So remember that whenever you are performing these operations like filtering or whatever operations you are going to go with, all of these operations will return one series object. How do you know that it's a series object? When you print it out on console, you will not see only 40 and 50. You will see the associated index values as well. So like 3 and 4, those are the indexes which are kind of given here in terms of that 40 and 50 positions. So 40 position is at 3 and 50th position is 4. This is not new to you. I know we already have seen this earlier as well. So this is a kind of filtering job we already have done in NP-array, which is still supported in series. And this is the basis of those operations which we are going to perform on data frame. So data frame is just a combination of series. So whatever operations we are performing here on series, we can perform them directly on the data frame. Now, negative and positive indexing we already have seen earlier in list and in NumPy. Maybe the values, the indexes are not there in this array. That's the reason in -1, or maybe negative indexing is not supported right now. Filtering is supported as it is supported in NumPy. And finally, there is something called as a slicing. Again, nothing new. We already have seen that earlier as well. All we can say here is print, I'll say S1 of, let's say 0 to 2, for example. So let me just come back here and say S1 of 0 to 2. You know what does it print? It prints the values from 0 to 1. 2 is not included, so 0 to 1. That's how it is going to print the values. Okay, now let me just come back here, try to print some more data. I'll say it's better we can just comment out all of these things, because it is unnecessary creating a chaos here. Not able to understand what exactly is printing, what exactly is not printing. So this is not supported. So precisely, I'll say that this is not supported. So I'm going to add one more comment here. So when you run this code, I'm sorry, I did not include this. So when you run this code, you see that it is printing values like 0 and 1. So 0 and 1 means it's going from 0 till 1. 2 minus 1, 2 is not included here. So this is a 0 to 2. I hope you can recall when you are going for slicing example, it's not necessary that you have to pass both left and right values. What if I say 2 colon? 2 colon is going to print all the values starting from 2 up to the last value, up to the upper bound. So precisely it's going for 2, 3, and 4. 4 is the last value, and this is how we are getting the values. Exactly like what we have seen earlier in list as well as in NumPy array. Let's come back here and say this time I'll not mention the left hand side value. I'll say 0 to 3. So basically I'll say colon 3. That means it's 0 to 3, 0 to 3, and of course you will expect the values from 0 to 2. That's it. This is the way we are kind of going from lower position to upper position, or lower bound to upper bound. And finally, this is again the same example I showed you earlier as well. S1 colon, and when you say colon, colon will give you values from 0 to last. 0 to, in this case, 4. That's it. So lower bound to upper bound, lower bound is 0, upper bound is the maximum values present in that series. So this is something which we already have seen earlier as well. So when you talk about something like this, a series object is kind of a new object or new collection which is having values associated with the index positions. That's a little bit different than what we have seen in NumPy array. But behind the scene, the series object is kind of created on top of NumPy array. Now the last example of series, and then we'll move on to the next one, that's data frame. So this is maybe function 3, and this time I want to create a series object, not by using a list, but by using a dictionary. I showed you that example yesterday as well. So probably I'm going to say pd.series, in which case I want to create a new object, let's say based on some data. And in this case, I'll say model. This is my data for a car. So model is I-20 again. Let's say company. Sorry. Company is a Hyundai, and the price, let's say, is 7.5. That's it. So this is a dictionary. We are passing it to the series object to create a series out of it. Let me see how that series looks like. We already have seen that yesterday, but still, I just want to take a look at it quickly. So you know that these are the index positions, and these are the values we are storing on those index positions. So precisely, if I want to get value 7.5, I'll have to say price, I'm sorry, here it is, price is equals to S1 of price. So basically, this is the way we are kind of getting the value from a position. Here, the position is string value. So position is price, position is company, and position is something like a model. So this is, let's say, company, and this is model. That's it. This is the way we can get all the values from this series object, company. Yes, we can get those values like this. Please do not mix those two concepts. This is a dictionary. This is completely different. While this one here is a series object. So series and dictionary, though they look similar, though they are having a little bit similar requirement, but still they are completely different. One is having a key value pair collection. The other one is index and position, index position and the value kind of pair you can think of. So basically they look similar, they have the similar concept, but behind the scene, they are implemented completely differently. Dictionary is a native supported by Python, while series is given by pandas, and pandas series is based on NumPy array. So it is completely different implementation. So don't mix those two concepts. They look similar, they work similar and work with the similar concept, but implementation behind the scene is completely different. Okay, so I hope you must have gotten the concept of series. Now let's close this one and continue further with the next one. This is a little bit different and important for us, at least for those who are going for machine learning. Anyways, coming back here, I want to again go back to the pandas, because without pandas, we cannot create a new object of data frame here. Now, again, as usual, I'm going to say import pandas as PD, and it's not required, but it's okay, and it's better to have it imported somewhere so that it will be easy for me to use it whenever I need it. This is pandas. Again, I'm going to go with the second data type. First one is the series, which we have seen yesterday. We have just revised it again, and now we are going to combine multiple series object together to create a kind of data frame. So let's say this is my function 1, function 1 as usual. And here I want to create a data frame. Now, before I go for the data frame, let me just simply compare all of these objects we have seen so far. So you can see the difference between a series and a data frame. At the same time, difference between a list and an array. So as usual, this is kind of, this is a kind of a list. We are going to say list is equals to, as simple as that. Maybe I can say 10, 20, 30, 40, and 50. Let's print this L1 and say this is going to be L1, and again the type is equals to L1, as simple as that. Let me just go back, print a dash in between, so it will be easy for me to differentiate them. This is a list. Okay, let's create an array out of it. Maybe I'll say this is going to be an NP array. That's the reason why I imported that there. So this is an array which can be created by using NP array. That's it. I'm sorry, NP array, like this. And probably this is going to be A1, this is going to be A1, this is going to be A1. This is an array. The next one is the series object. I can come back here and say this is the series object. We already have seen it working. That's S1, for example. This is again S1, let's say S1 and then S1. That's it. And now we are creating something called as a data frame. What's the difference between that? I'll show that here. Watch carefully. So this is generally referred as a DF, stands for data frame. So how do we do that? To do this, we are going to say pd.dataframe, excuse me, and we can pass the same values 10, 20, 30, 40, 50 here. Okay, I'm sorry, I need to say pd.series here if I want to create a series object. So now this is pd.series and this is a pd.dataframe. Let us see what's the big difference between these two. So this is again df, 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 and df. Let's call that function. So it will be easy for us to compare all of these collections because all of these are actually collections. When I run this code, probably you can understand that the very first one is the list. It shows me, what the hell? I forgot to say type of everywhere. My bad, not big deal. I'll say this is one, this is the one as well. And this is the type function I'm supposed to call. Okay, so let me run this code one more time. Hopefully you can see that now. This is the L1 having all the value, all the same values like 10 to 50, and the type of it is list. A1 is having the same values, but the type is ND array because we created a NumPy array out of it. This one is a little bit different. This is S1. That S1 is of type series, and series is one where we are kind of having the values, something like 10 to 20, 30, 40, 50 on the index positions, like 0 to 4. Okay. Now, DF is a little bit different. I don't know whether you can see this properly or not, but it's better I just try to format it in a different way. So what I'm going to do here is, instead of saying this, maybe I'll just say S1 is equals to, and I'll print S1 separately because there is a difference between displaying it in one single array, one single line, and displaying it on a different line. So you will see the difference, and then you will understand how series is different than data frame or how data frame is different than series. So let me print it separately, df1. Let us run this, and probably here now you can see that this is the S1 we are talking about, having the values 10, 20, 30, 40, 50 based on, which are stored on the index position 0 to 4. While this is a data frame, can you see that? A data frame is almost similar as a series. I mean, if you just look at this part, it feels like you are having a series here. But if I just zoom it out, hopefully you can see a 0 here. 0 here is nothing but the column we are talking about. So basically, when you are talking about 0, it's not giving me it as a twice. Vipin, I understand what you're talking about here. Is it giving me twice? No, it's not. This is a different concept. That's the reason why I'm comparing all of them together. Now, why it is a little bit different than this? They're a little bit different than this because this one, and this one, all of them are one-dimensional array. Dimensional arrays. So basically, list, array, and series, one we have created here, all of them are one-dimensional arrays, while data frame is multi-dimensional array. Now, when I say multi-dimensional array, probably you can understand this is the 0th dimension. This is a kind of, maybe you can say matrix. Matrix is having, let's say, rows and columns. So this is a row, this is a row, this is a row, this is a column. So 0th, what you see here is the column position, and this 0 is the row position. So this is a multi-dimensional array. Do I have any proof? Of course I have a proof. And to prove that fact, I'm going to bring it in second function somewhere here. And let us see and let us prove the fact that this is a multi-dimensional. It's not like I want to prove the fact, but it's like more like I want to show you different properties of a DF. So let's see how it can be done. Instead of saying DF1, I'll say DF. Makes sense. Like last time, I'm going to print the DF values like this. So it will be easy for us to judge what exactly is coming here. This is DF, and probably just after it, I want to print all the properties of it. So for example, what is the dimension? So that's very, very important for me right now. So the dimensions is equals to df.ndim. I hope you can recall the same thing we have talked about. Print, I want to see what is the shape of it. So probably df.shape, because data frame is made up of series is made up of NP array. You can easily get that all the different properties we have seen in array NP array are still available in series, are still available in the data frame. I hope you can understand that. So this is NP array. That's sorry, this is data frame. Data frames ndim, data frames shape. And if you just come back here, I'm going to come back and say what is the data frame? What is the data frame? Say D type. It's not D type, it's D type so. D type so because it's having multiple columns within it. Let us run this code and see what exactly is showing me here. Seems like this is the DF, this is the DF, which means in between these two, what we are getting is the value stored in that DF. Understood. This is more important for me. Look at the dimensions. It's telling me there are 2 dimensions here. Now 2 dimensions simply means we are having rows. That's the first dimension, and the second is the column. So rows and columns. That's why it is having 2 dimensions within it. The shape here is 5 by 1. 5 by 1 means we are having 5 rows, and within every single row we are having only 1 column. What's the shape? Sorry, what's the data type? My bad. It's not the shape, I copy pasted it. It's like a data types. So if you look at the data types, we are having only 1 column right now. So on the 0th column, we are having the values integer 64. So that's what it is telling me. And the total object, the total data type of the data frame itself is an object. That's fine, that I can understand. So more or less, if you pay attention to that ndim here is not 1, ndim here is 2. If you do the same thing on series, you see that a series will tell you the ndim is equals to 1 because series is a 1-dimensional array while data frame is multi-dimensional array. So when I say multi-dimensional array, that simply means we are having rows and columns. So that is how the values are getting stored behind a scene. Probably if I just pay attention to what the values here are representing, so you can easily say that they are representing a kind of a tabular structure, the one which I showed you yesterday, if you can recall. So this is a kind of a table and this table is having all the different rows and columns. Right now there is only 1 column, but you can create as many columns as you want, and we are certainly going to do that in a minute or 2. So this is a kind of a data frame. This data frame is having rows like this and the columns which are vertical. You can say that there are 4 columns right now and there are 2 rows here, maybe 3 as well if you want to consider the first one. So probably what I'm saying here is the data frame. Please remember a few properties here, very important when you are trying to get the values from the data frame. So this is the data frame, not data frame so it's data frame, it's single one right here. What you see here horizontally is called as a row, that you understand. But for me, I'll just mention that a row where the axis is equals to 0. So whenever you are saying the axis is equals to 0, you are referring the fact that you are talking to a row or you are getting a row out of it. So these two are nothing but axis 0, a row. Now what is axis 0? I'll mention that in a minute. But right now just remember axis equals to 0 means you are talking about a row. While when you talk about axis equals to 1, this is nothing but a column you are talking about. So basically this is a column and axis is equals to 1. Coming back here, I'll say that this is the axis 1, that is a column, something like this, and there are 4 columns out of it. So in this data frame, or the one which I'm showing you right here, this is having, let's say, 4 columns, 4 you can say vertical separations of your data. That's it. That's a simplest concept you can see here. This is exactly similar to the SQL table what we have seen yesterday. So in MySQL, we created a table with different columns. We inserted some rows. Exactly on the similar lines, we are creating a data frame here. Right now, if I look at this data frame is having only simple values in one single column. That's the reason why we are not able to get it as a tabular structure. So right now we are having only one, but nevertheless, I'm going to create one more data frame just to give you a quick idea about what exactly this is going to be. So probably I'm going to start writing another data frame here, which in this case is not going to be maybe a data frame with only one column. I want to create multiple columns as well. So let's see how it can be done. So when you want to create multiple columns, you just have to pass multiple arrays like this. For example, let me come back here and say this is 10, 20, for example. Let's say 30, 40, let's say 50, 60, say 70, 80, excuse me, and 90, 100. So let us understand what exactly it is all about. And probably you can see the difference between what we have seen last time, excuse me, and what you are going to get here. Let me just say here, the type is equals to same again type of data frame, just to prove the fact again that we are talking about a data frame here. And very important again, these two properties we have seen last time. One is the dim and the other one is the shape. Not interested in the data types right now, just we know that we are storing the number values or integer values here. Now see how does it look like. This is a kind of a data frame. We already have seen that because we have created one. The dimensions, as usual, there are two. So at least there will be two dimensions because this is multi-dimensional array, and the shape is 5 by 2. Now, what do you mean by 5 by 2? 5 by 2 means 1, 2, 3, 4, 5. There are 5 rows, and 1, 2 vertical. These are the columns. So basically now it feels like a table here. So probably now you can understand there is a 0th column, there's a first column, and there are 0 to 4 rows. So now this looks like a table. This looks like a tabular structure. So probably you can understand now that this is a kind of data frame which is having multi-dimensional value, multi-dimensional array. Let's come back here. Let's create quickly one more. Let's say print, print, let's say dash of 80, for example. And probably I just want to create a very simple data frame one more time, but this time I'll create it in a different way. So pay attention, pd.data frame. This time also I want to put the values, but let's say whether you can understand this or not. I'm going to say 10, 20, 30, 40, 50, and say 60, 70, 70, 80, 90, and 100. So let us see what does it give me back. I'm just going to print it now. We know that it's kind of again a, okay, it's better we can print all of this information. This is a kind of data frame which is again having two dimensions, and the shape, you can see that it is having 2 rows while 5 columns. 2 rows while 5 columns. So basically first one is represented here. This is the first row and this is the second row. Both these rows are having exactly same number of columns. Vertically there are 5 columns. 1, 2, 3, 4, 5. Looking at this, you see that this is my first row, this is my second row, this is my third row, this is my fourth row, and probably this one is the last and the fifth row. So that's how we are getting it here as a 5 rows, 2 columns, and we are getting here as a 2 rows, 5 columns. Look at the difference between 2 by 5 and 5 by 2. You can easily understand that now. So this is a 5 rows, 2 columns data frame, and this is 2 rows, 5 columns data frame. This is how we are just going to group them together into different rows and different columns. Prithya, what are you saying? Getting the type error, finding element must be 2 or 3 tuples got 70. It means you are not having the equal number of columns in your rows. So probably you are missing somewhere and you are adding more column in one row than the others. So this is the reason why you are getting that error. Make sure that you are having exact same number of columns in every single row. This is a kind of condition. This is a kind of a restriction we already have talked about earlier in NumPy, right? Exactly. One more. That's what I said. You might have missed it, or you might have added one row, one column more column than the others. Anyway, so looking at this, you have two examples, 5 by 2, and this is a 2 by 5. So this is how we can, just look at the difference between these two, and probably you can understand how the values or how the data frame is created here by using the numbers. Guys, can you please just give me a confirmation whether have you understood this or not? Okay, at least 1, 2, 3, 4. Yeah, that's okay. So I got at least a confirmation of couple of you. That's more than sufficient for me to understand what is currently going on. Okay. Okay, so and now I'll just go back here, get one of them. Doesn't matter which one I'm using because anyways, it is going to give you the same information for all of the other data frames as well. Similar, not same, but similar information. Check this out. In this case, I want to see a couple of more properties which are available in data frame, which are not there in series or not there in NumPy array. This is a little bit different than what we have discussed earlier. So pay attention. I'm going to come back here and say print. Probably this time I'm going to go for different properties. Like the property which I'm talking about here, few properties you already have seen last time. For example, ending, or for example, D types. For example, let's say shape. These properties you already know. We already have talked about them in NumPy. We already have talked about them in series. Now they are already there. That's the reason we don't have to talk about them again. But the properties which are not there, the methods which are not there in series, which I'm talking about here, pay attention about this one. Now, generally what happens here is when you are reading the data, maybe from CSV or maybe you are having a huge data, it becomes a little bit difficult for us to see what exactly the number of rows available there. Now, let me add a couple of more so you can understand what is going on. So probably I'll just add a couple of more. I'll say this is 13, 14, 15, 16, 17, 18, whatever. I'm sorry, 13, 14, 15, 16, uh, 13, 14, 15, 16, 17, 18. That's it. So I need a couple of more rows so it will be easy for me to demonstrate what I'm trying to say here. Okay, so in this case, now we are having, let's say almost 1, 2, 3, 4, 5, 6, 7, 8, almost like 8 rows. So let me come back here, call that function, run my code and see that right here, not 8, sorry, 9 rows. And there are 2 columns in each of them. Now, if I try to put this right here, if I say df alone, then it is going to give me all the values here starting from 0 to 8. Fine, I could understand that. But imagine a data frame having, let's say, 1,000 rows. It's impossible for me to look at all of these rows in one single page. So generally, I want to take a look at, let's say, data. How does it look like? And I want to guess some properties out of it. So it's not like I need to see the entire data to understand what exactly the data frame is talking about. It's like when you want to see whether a rice is cooked or not. It's not like you will eat entire rice and say whether the rice is cooked or not. What do? You take a grain out of a cooked rice and you just squeeze it and see whether it is prepared or not, whether it is ready or not. It's like the same thing we are talking about here. In Marathi, it is called as Shitavaram Bhatachi Pariksha, you know. So in that case, you take a grain of a cooked rice and just squeeze it and just see whether it is cooked or not. Similarly, I don't need to look at the entire data to understand how does it look like. I just want to see a couple of rows so I can see what type of columns we are having, what type of data we are having in those columns. So if you just want to take a look at it quickly, so probably you can say there is a method called as a head. Head will give me first 6 records or first 5 records. It can be configured. So it's giving me first 5 records. I know there are 9 records here, there are 9 rows, but it is giving me first 5 records just to tell me like what does that data look like. So maybe we are having only 2 integer columns. That's the reason why it is not impacting right now. But later on, when we try to read the data from CSV file, you are going to understand all of these things, what I'm trying to show you here. Ashish, we have to. There are many CSV files out there and we are going to read the data from CSV file. Just hold your excitement and then you will be able to see that. Let me first talk about the different methods available. You will see how they are looking here and then I'll get the data from CSV and I'll show you how to do these things. Okay. So it is telling me there are 5 records right here from top, and this is the kind of status of my DF, which is telling me there are 2 columns that are kind of having integer values. Fine, I'm okay with it. What if I want to read only first 3 rows? So this is kind of telling me this is the first row, second row, and third row. So I don't even have to go for 5 rows. I can just look at a couple of rows there and just understand what the data is looking like. This is going to be pretty much useful later when you are having ton of data in your CSV file. So just hold and I'll tell you how to get the data from a CSV file. But before that, again, I want to go from the bottom side, not from the top side. Head is giving me the data from top rows, top first row, top first 3 rows, 5 rows, whatever it is. Similarly, there is a method called as a tell. Tell is going to tell me like the last 5 records. So you can see that it's state 8, 7, 6, 5, 4. So it's giving me last 5 records. And like here, you can pass a number here to get last n number of rows. So basically I can get the last 3 rows. That is a kind of maybe you can say way to just take a quick look at what the data is there or how the data looks like inside the data frame. So there is a head and there is a tail. Now, sometimes I want to understand how the data is made up of, how the data looks like. So to understand that data in more better way, you can use these two functions, two methods, not functions, these two methods. One of them is called as info. Now, what do you mean by info? Info is going to tell you information about your entire data frame. See, this is the info output. It is telling me that this is a kind of data frame which is having, let's say, 2 columns, 0 and 1. First column is having 9 values, non-null values, while the data type of it is integer 64. And the second one is also having 9 columns, or sorry, 9 values which are not null. And this is the data type of it, which is integer 64. So in short, in the data types, we are having 2 integer 64 columns, and it's using almost like 272 bytes memory to load the data in the RAM. So it's giving me a kind of a summary of it. It's telling me the range index is 9, which means 0 to 8. We are having the rows starting from 0 to 8. There are 9 total rows, and this is how the values are kind of arranged here in my data frame. So info is giving me general information about the data frame. Now later on, when you are going for machine learning, it's not only sufficient to talk about the data frame. It's kind of required to understand how the data is looking like. Now, if you want to understand how the data is looking like, you have to go again and dive into statistics. Now, for example, if I tell you that on an average, every student has scored 50%, you can immediately get what is the IQ level of that student or IQ level of that class. So average will tell me what a kind of data we are representing here about a particular entity. So like this average, I want to literally calculate the average of all the columns and see how the data is kind of arranged there. To do this, probably I'm going to call another method called as a describe. Describe is more statistical information than information. Information will just give you kind of information about your data frame, like how does it look like, how many columns are there, what is the data type of that column, and so on and so forth. When you say describe, it is going to describe the data. You see here, this is the 0th column, this is the first column. So this is the count, number of values we are having. This is the mean is nothing but the average. This is the standard deviation. This is the minimum value, 25th quartile, percentile, sorry. Maybe you can say 50%, that's the median actually. That's something like 50th%, or maybe second quartile, third quartile, and the fourth quartile, that's a maximum. So minimum value, maximum value, median, mean, all this information is available inside this describe output. So describe is going to tell you how your data is dispersed. What is the minimum value? What is the maximum value? What are the different quartiles there? What is the mean value? Mean in the sense this average value, and how many records are there in every column. Of course, this is possible only when you are having integer or float data inside those columns. Of course, it's not possible to go for a string data and to get the mean out of it. You can't. So basically, when you talk about the statistical information, or if you want to get the statistical information about your data frame, you can call a method called as describe. So describe is the one which you are going to use for this purpose. So there are two methods I talked about. One is called as info, and the other one is called as a describe. So this one is going to tell me the statistical information about every column, and this one here is going to tell me generic information about your data frame. Number of columns, the data types, how many records are there, and so on and so forth. Enough about this. Now what we were doing here, it was a simple integer data. So now let's take a look at better, and you can say a kind of real life example. Remember last time I talked about getting a where is it here it is, getting a car's information. So what I'm going to do here is like, let's continue this further and say I want to have, or I want to add few car informations here, you know. So it's not like I'm going to use only one car, but I want to use multiple cars. This is a kind of a one car. So probably I want to go for adding couple of more and understand what exactly it is going to be all about. So probably I'm going to say this is i10. Let's say this is nano, for example. Hyundai, will keep it as it is. I'll say Tata. We'll say this is 5.5 and then say this is 2.5. Now, when you talk about a series is a kind of single dimensional array. While if you look at this particular example, this is a collection of collections. This is rather a list of dictionaries, means it is a double dimensional array or it's a two-dimensional array. If it is a two-dimensional array and if you want to create that using pandas, pandas does not give you a series for multidimensional, but it gives you something called as a data frame. So precisely, I can create a data frame out of it, which is kind of giving me the list of dictionaries. You already have seen one series created by using a dictionary. Now we are having multiple dictionaries. I want to create a data frame out of it. Let us see how the data frame looks like. So probably I'll call that function phi and see how does it look like. And precisely, it now started looking as a table. Can you see that? This is my 0th row. This is my first row. This is my second row. While this is my column 0, that's model, column 1, that's company, and column second, that's price. So when you're talking about a DF, this DF is having a near to the real life example. Here, whenever we are talking about a number of car data, you can put that data together into a data frame and it starts looking like a tabular information which can be represented in one Excel worksheet. That's the reason I said that pandas is a kind of Excel for Python. Okay, Tanya, you're saying when I'm writing the df.shape, it gives me a tuple object, not a callable error. Gives me tuple object because not callable error. Not getting you. Of course, okay. You're saying, Tanya, did you see that? What you're saying? df.shape. df.shape is a property, not a method. Did you see that here? When we are talking about the shape and other things, this is a kind of a property. It's kind of an attribute, not something, I'm sorry, not something that, not something that you are going to use it as a kind of a method. That's the reason why you are getting an error. So Tanya, just remove that parenthesis and probably you will be able to do that. Okay. So hopefully you can see what is error there. You are trying to use it as a method, whereas it should be a kind of a property you have to use. Anyways, so now you understand, like, this is a kind of a data frame which we are trying to talk about in a real life. In a real life, we can have multiple car information and I can put all of that information into a data frame, and this is how it will look like. Now, enough about getting the data directly from hard-coded values and hard-coded columns like this. Now, someone is looking for CSV. Ashish, this is an example of how to read the data from CSV, because this is the example which you are going to see frequently in machine learning part of the world. So let me say this is page 3, and I need to get some data. I hope I have turned off them right here. Okay, so probably I'll just look at, we already had that machine learning batch last time. So I'm going to go back here and say data set. And right there, we are having so many of them. So there are many data frames, examples. These are the CSV files. I want to use a couple of them. I want to use, let's say, salary data. Do I have it somewhere? Here it is. That's a simple CSV file. It has 2 columns, years of experience and the salary, So what I'm going to do here is I'm going to copy this CSV file. I'll put that in my current directory. I don't necessarily have to. I can directly pass it as a kind of a path there and still it will work, but it's okay. I'm going to make it really bit simpler. So I'm just going to copy this here. At the same time, I'll also pass the CSV on your chat, so you can easily copy it, download it on your machine, and you can start writing the code along with me. Okay. Prashant, if you have not gotten the concept of access, it's okay. Just leave it right now. When it is required, I'll talk about this. Right now, just focus on what I'm trying to show you. Okay. Ashish, this is the example for you. You were looking for how to get the data from a CSV file. So look at this. Again, I want to read the data from that salary. What is that? Salary data.csv. Fine. I'm going to come back here. I'll again import the pandas. I'll say pandas as PD as usual. And we'll say numpy as np. np is not required. I'm telling you one more time. np is just a kind of, maybe I'm adding it so that in case I need it, then I'll be using it from that np. I don't have to import it at that time. That's the reason why I'm kind of using it here. Okay. Otherwise, you can easily see that probably it's very simple to just get all the things only by using pandas. NumPy is a kind of not required here. But anyways, we need it sometime later, so I'm going to use it in this example. Okay, so probably I want to read the data here. How do I do this? To do this, I'm going to start with function, I'm going to start with function one, as simple as that. And inside this function, I want to read the data from that salary data. How do I do that? Now to do this, probably I'm going to say df, which is a data frame. Probably before I talk about that method, I'm just going to open this data, double click on that CSV file, and you will see that this is how the CSV is kind of arranged. This is column 0 and this is column 1. So there is a column years of experience and there is a column salary right here. So if I read this data, before I read the data again, just quickly, it's already open, I guess, somewhere. So I can double click on this and I can open it, or maybe I can open it with Excel, not with the numbers. I'm going to open it with Excel. So you will get an idea quickly, like how does it look like? So you can understand this is my row 0 and this is my row 1. So this is the reason why I said that it can be represented as a Excel sheet, Excel worksheet, precisely. Okay, so probably I'm not going to need this one right now. So I'll just close it and I'll come back to my code right here. And now I want to read it as a kind of a data frame. How do I do this? This can be done by using pd.readcsv and just give the path. So the path here is salary data.csv. That's it. Let me just go back here and say print df and see what we are having inside the df so that we can understand whether we are getting the data or not. So let us run this code and probably you will see that we have read the CSV file data. There are many records here, almost like 32, I guess. And this is how we are kind of getting or reading the data from CSV file. So CSV is having two columns, years of experience, and this is the salary. It understands the format in which the data is added in that CSV. By the way, CSV stands for comma separated values. If you pay attention, little bit closer attention, you see that every single row is having one comma, which is separating years of experience and a salary. The same is true here, years of experience and a salary, years of experience and a salary, and so on and so forth. That's the reason why it is called as a CSV. CSV stands for comma separated values. So now we are having the data here. I want to understand how the data is looking like. Probably in machine learning, I would have gone for an example like if you are having years of experience XYZ, what will be your salary? I could have answered that question in a machine learning, but to do this, I need to understand the data. To understand the data, I need to put that in a data frame. And because we just have seen a couple of methods in data frame, which will give us more insight about it, I can use that by saying print, say df.info, if you can recall, and print df.describe. Again, this is more of statistical information. So nevertheless, I'm just going to come back here. I'll say this is a kind of a separation in between so that we can understand how the data is laid out in my Excel, that CSV file. So this is an info object. This is an info methods output. This is going to tell me that this is a data frame. No doubt it is. There are 33 entries, 33 records. Out of them, there are two columns, and out of them, first column is float and the second column is integer. All of them are non-null. In a sense, the data is not missing. Everything is looking great. Seems like it is using 656 bytes. I don't care about that. What do I care about here is this one. Not right now, but later in machine learning, you definitely will need it. This is the statistical information. Without statistics, you can't write a single line of code in machine learning. So those who are willing to pursue their career in machine learning, for them, statistics should be the bread and butter for them. So unless you know statistics, you can't go for machine learning. Anyways, that's a different story, but that's the reason why describe method is giving me a kind of statistical information about both the columns. You see here, it's giving me the count, mean, standard deviation, minimum, maybe percentile, median, and so on and so forth. So probably what you see here is a kind of information about this DF. Now, sometimes it becomes a little bit difficult for me to see entire data. In this case, we are having 33 records. I can't just look at all 33 records and understand every single thing about it. So that's the reason I talked about two more methods here. One of them was head, where we can see the first 5 or first 3 or first 4, whatever it is. And then we can also see the last few records by using a tel. So again, when you talk about the head and tel, both of them are going to do the similar job. The only difference will be, instead of reading the entire data, it is going to read only first few records. So it is going to tell me like these are the first 4 records, these are the last 4 records. That's it. This is the way we can do it. I hope you can understand what we are doing here. Okay. Why serial number is coming? Should have only two columns. Which serial number are you getting here? Who's that? Sripati, which serial number are you talking about? Sripati, which serial number are you talking about? 012. Very good. Thanks for asking that question, Sripati. If you can understand something, this is not a serial number. This is kind of an index position. Did you understand something? When you talk about the data frame, how data frame is constructed? I said that data frame is constructed by attaching more than one series of objects together. So what we are getting here is like, this is the index position. This is the index position. This is the index position of these rows. So this is my 0th row. This is my first row. This is my second row. And all this information is stored on the 0th index. If you can recall series, I don't think this is going to give you a kind of a big trouble. And this is not coming here automatically. All these rows are stored on the 0th index. So that is the indexed position. Pandas data frame is based on Pandas series, and series contains two things, index and values. That's the reason I talked about series earlier. So if you have understood series, you can say that a series object is having an index and a value. Multiple series coming together to form a data frame means every single column itself is a series, which means all these columns will be having common common index positions like 0 to 32, which are getting shown here on the left hand side. Shripati, is your doubt clear now? Rohit, maybe it is saying a saving index. Absolutely right. Like Excel is showing. Preeti, yes, Excel also shows it, but here it uses that index value to add or to create that row on that particular position. For Excel, it's okay. It just shows that information. But here, without this index value, it's not possible for us to get the values from that Excel sheet. Okay. From that CSV file. So now if you can understand what we are looking at, it's kind of a data frame, which is looking like a table. And if I just look at that table right here, this is how it is kind of laid out. Maybe there is a years of experience column, and there is a salary column here. I mean, there are only two columns within our CSV file. So we can understand it from this perspective. This is a years of experience. This is the salary. Okay, so enough about this now. Now let's start performing some operations on top of it. Let us see how it can be done. I'm going to just come back here and say this is going to be my function 2. And right here, I want to again read the same data. Now, instead of me creating the data again and again, it's better we can just read the data right here. See, say salary data, Now, more important part for me is like, how can I start getting the data out of it? I mean, till now we have created the DF. We have seen different methods out of it. We try to look at different properties. We try to look at different aspects of the data frame. Everything is okay, but how do I perform the operations? Operations like indexing, operations like slicing, operations like filtering, operations like sort by, and so on and so forth. How do I do that? That is more important, because unless you do that, you will not be able to understand how powerful data frame is, or how you can process the data, or how you can analyze the data. So this is something which is kind of pre-processing of your data. And unless you do this, you cannot use this data for your further machine learning exploration. Okay. Yes, Pranit, you can. Not a big deal. It's okay. You can watch the video later. Okay. No problem. Here you are talking about a DF which is having a salary data, and the salary data is having two columns, years of experience and something like a salary. Now, if you are talking about this DF, I want to start getting the data out of it. Now, see, we already have looked at how the salary information looks like. Better, I'll just try to put it somewhere, so it will be easy for us to pay attention to what we are getting, and then we'll start, getting the operations executed on this to get the actual data we are looking for. So this is how the salary and years of experience are added inside that DF, and these are the positions. 0th position is where you are going to get the years of experience, and the first position is where you are going to get the salary. Now let's try performing some operations here. This is a kind of indexing operation. You know what indexing means? Indexing means you are trying to get a value at a particular index. Watch what happens. I'm going to go back here and say DF of, probably I want to get the 0th value, or I don't know what exactly the 0th means, but still I just want to give it a try. If it is a series object, df of, oh sorry, s1 of 0 would have given me the value stored on the 0th index, you know. So that's how it is. Let us see what do I get here when I say df of 0. When I say df of 0, it's kind of not working. It's telling me, hey, are you kidding me? You're not able to get anything out of it. Why you are, I mean, why you are getting an error, or why it is not giving you anything here? The reason behind this is, now this is not a single dimension data, or this is not a single dimension object. This is the multi-dimension. And when you say it's a multi-dimensional always talk about rows and columns. Now the first one we are using, that's a 0, what we are trying to refer here is the actual index of your column. And unfortunately, there is no column with the value 0. And that's the reason why it is not working. Oh, so df of 0, it's something like we are trying to get the 0th row, but row does not exist there. That's the reason why you are getting an error. By the way, I'm sorry, not row, sorry, my bad, it's column. So the column does not exist here on the 0th position, and that's the reason why you are getting an error. Do you see that? The column name here is years of experience, and the column name here is a salary. I'm trying to get it by using 0, which is not there in the list, and that's a reason why it is not working. Okay, not a big deal. I'm going to get the value from the column name. Can I do that? Of course, yes. You can say, hey, give me the years of experience now. Can you? So if I say run, see, it happily can give me all the values in that row, in that column. So basically what you get here is a kind of a series object, but this series object is giving me all the values of years of experience. So years of experience is my column 1, and I can easily get all the values within that by using something like the column name. So this is how we can do it. Okay. What are you saying here, Vishal? So I added the same folder, but it's not showing in the pie chart. Don't worry, just right click on this one and say synchronize. Sometime it happens, or reload from the disk. It sometimes happens. So just reload and it will work. Abhijit, can we use the pandas and numpy to read the perform the operations on the header that is on H file? Can we use pandas and numpy to read and perform operations on the header file? Not getting you what you want to do here, but if you can precisely tell me what type of operations you want to perform, I'll tell you whether it's possible or not. Generally, when you're talking about the pandas, it is possible to perform operations on these values or on these columns and rows only when they are in the form of tabular, or they are in the form of table, or they can be represented as tabular information. So unless you can represent that as a tabular information, you will not be able to perform any operation on them. Okay. So Abhijit, exactly what you're looking for is not, I'm able to guess. That's the reason why I'm going to keep your question pending. If you're having a particular scenario, just tell me, we'll see whether it's possible or not. Anyways, coming back here, I got the value, I got the row, complete column here. All the rows inside my column, years of experience, not a big deal. I'm going to do the same thing here, and I'll say, hey, give me all the salary values. Not a big deal. I'll see that right here, and guess what? I got all the salaries here. Very, very, very simple. I don't know whether you can map this or not, but yesterday we have done something like this. Select, maybe I'll say years experience from a table. Let's say there is a table called as employees, or there is a table called as a salary data. And imagine that we are getting only one column out of it. We did that yesterday by using this particular query. Here we can easily say that, hey, select years of experience from salary data, or hey, just give me the salary column from that salary data. As I told you earlier, we are going to perform all the SQL operations, which we already have performed yesterday on MySQL. We can do the same thing on the DF here, or we can do that on a CSV file there. So this is the way we can do it. In Excel, I would have literally selected only one column, which means I would have done that directly on top of Excel like this. See, I'm going to show you that right here. So probably I could have done that by using this one. So this is going to give me a particular column. So if I need that column, I can move it here. So I can select the entire column. The same operation can be done here by using something called as something like an indexing operation. So indexing can give me all the rows within one single column. I hope you are getting it. Right now, there are two columns. I can get them individually, or I can get both of them at the same time by saying, hey, I need both of them. That's years of experience, and the other one is the salary. So what you're saying here is exactly what you have said yesterday, like select star from, or select, let's say, years of experience again, experience, experience comma salary, which is nothing but select star from salary data, because there are only two columns. So I can still do that. It is going to give me exactly the same scenario what I'm talking about. So I need both the columns, like years of experience and salary. Yes, I'm getting that. As simple as that. So when you are trying to get a column information, you can do that by using a square bracket. If you want only one, just specify the column name. If you want multiple, then put them in one single in one single list, and you can get it like this one. No, Adesh, you cannot perform negative indexing here. As I showed you earlier, negative indexing is not also possible on series object, so that's not possible here as well. Anyways, coming back here, I hope you can understand how to read the data from salary and how to get the column information out of it. Now let's perform some better operations, some kind of real life operations, which we are interested in. So probably I'm going to read that data again. I'll just keep one, just a couple of records in front of us so that we can understand what we are getting there. So this is going to be function 3, and this is where I'm going to start performing all the operations here. Yes, wait, Abhilash, you are going to get it. Utpal, just wait, you are going to get that. And Adesh, no, it's not okay. How to get a particular row? That's what I'm talking about now. That's the reason why I said, let's look at the more better example, or you can say more realistic example. So not every time I need all the rows within a column. For example, sometimes it's like, I want to go for let's say salary of a person who is having years of experience like 1.5. How do I do that? Now to do this, I know the years of experience 1.5 is on the second index. So probably what I'm looking for is the salary of a person who is on the second index here. So how do I get that particular data? To get that particular data, this is still again in terms of indexing, it is true. So I'm going to do that right here, and then we'll come back and add one more example there. So this is like get a specific row. So I don't want to go for all the rows. If I want to get only a specific row, I can do that by using the same method. So it's like, I'll just copy this here and I perform that operation here. So probably I can say df of experience of, this is a two-dimensional array. So this is going to be representing my row, and this is going to be representing my column. A column and a row, my bad. The first one is the column and the second one is the row. So first one is the column. We said that this is the years of experience, and the row I'm looking for is let's say 2. So I'm going to say give me only the row 2 instead of giving me all the rows there, So now I'm going to get the value, which is something like 1.5. So probably I'll just mention what am I trying to put here. So say experience exp at second position, which is something like this, df of years of experience of 2. So the years of experience and the second position is 1.5, which is very true. You can see that here. How do I get it on the salary basis? So years of experience, no, salary at second position. How do I do that? It's going to be exactly similar. Just use the salary column name. And this is the way you can get a particular information here. 1.5 and 37,731, whatever it is. So yeah, that is really working fine. What are you doing here? Actually, this is a kind of a where clause. For example, select years for experience from salary data, where maybe I'm just going to call it as an index, where the index is equals to 2. This is exactly what we have done yesterday. So all of these operations we have talked about yesterday on MySQL data, we can still perform all of them right here by using a very simple logic, by using this pandas object. So this is the salary data, that's how it is. But what if I need both of them? It's not like I need years of experience and salaries separately. What I need here is like, I want to get both salary and years of experience on the second position. So probably this is what I'm looking for. How do I do that? Same story. Just get both the columns and then put the row index here. So if I do it here, probably you can understand, oh, there is no two. What is it saying? Okay, this is going to give me a data. My bad. Yes, I think this is what we are getting here. And what is it saying? Okay, so it is saying like, no, it's not possible for you to get all the rows here because this is giving me a data frame back. Okay, let's look at this one. This is multi-dimensional array. I forgot to do that. So this is the multi-dimensional array. Maybe I can say the data type, or if simply the type is equals to this. Sorry, the type is equals to this. And probably you can say that the type is equals to, let me put this one in type, and probably you can see that this is not a series object, rather this is a data frame object. This one is a series object, this one is a series object, but this one is a data frame object. And if you don't believe me, let me try to put it here. So I'll try to put that right here. I'll say the type, which is equals to, maybe I'll say df of salary of 2. Maybe I can just go back here, forgot to say that. This is the type. So compare both of them. One of them is kind of a simple series object, which is telling me that, oh, this is a value integer 64, because we are looking at exactly a single value out of it. Probably we are saying salary at second position, salary at second position. This is the value we are getting here. Whereas when we talk about multiple data, multiple columns like years of experience and the salary, what it is giving me, it is giving me a kind of, a data frame here. So basically, whenever you are having multiple columns within it, it's not going to be a single value, or it's not going to be a series. It is going to be rather a complete data frame out of it. Why it is having a data frame? It is having a data frame because we are having multiple columns within it. When we have multiple columns, means we are having multiple, multiple dimensions. So it will be a kind of a data frame. Look at this one here. This is the data frame. When you talk about this, where is it? Let's look at this one, not this one, this one. So when you are having something like this, you can say that you are talking about only one column. My bad. Here it is. So when you're talking about salary, you're talking about only one column. And if you're talking about only one column, then probably you can say that we are talking about a series, because every column itself is a series. So maybe I'll say the type is equals to type of this. You will see that this is going to be a series. Every column here is a series. Look at that. Every column is a series. A series value is nothing but a simple value here as an integer 64, and multiple series together are giving me a kind of a data frame. When you talk about one single column like series, like salary, like years of experience, we are talking about a series object, because multiple columns represent multiple series, and multiple series combined together to give a kind of a data frame. So a data frame is a concatenated series. Absolutely, Preeti. So that's the reason why I said that multiple times. Multiple series object coming together to form something like a data frame. So a data frame is nothing but a combination of multiple series. I hope you can understand that now. So whenever you are performing these kind of operations, please keep this in your mind, that whenever you are going for multiple values, multiple columns, you are talking about a data frame. And if it is a data frame, you can't directly go for only one value. This is again going to give you the data frame, which means we'll have to go for individually a column this or column this. Isn't there any better option? Of course, there is a better option. So if I want to perform this operation, I will show you that by using another method. It's called as iloc or ith location. Just wait for it. So I'm going to put this in comment for a minute, because this is representing a data frame and it's not as easy as you think here. So there is a better option. The better option is something called as iloc or ith location. We'll talk about that in a minute. But before that, I want to come back here and perform some real life examples. Like what I showed you here is like how to get a column, how to get a row within a column. Now we will try to go for the next example, something like the filtering. More important for me, or rather the most important for me, because filtering is the way we are going to understand the data a lot. Like how many rows are there which are satisfying my criteria? How many rows are there which are maybe out of, or which are not having the correct values, or how many rows are there where the values are missing, so on and so forth. So if I want to perform these kind of operations, then probably I can easily go back and perform these operations by using these steps. Like step one, where I can go for filtering. Now, what is a filter? I hope you can understand. Filter is nothing but the way we are kind of adding a criteria and getting a values based on that criteria. Anuja, what you are saying? Line number 44. Line number 44 is where we are getting the salary column and not the entire column values. We are getting only the second value, so the second row out of that salary column. Look at this one, salary column. This is the entire column, and we are reading the value of the second row. So that's what we are getting here. Anuja, I think you got your point. Okay. This is the type. The type of it is integer 64 because we are talking about a single value. If I say the entire salary, this will give me a series. If I look at a single value out of series, it is going to give me either integer, float, string, whatever the value is there on that row position. And if you look at the multiple columns together, it is going to give me a data frame. Anuj, are you okay with that? Okay, no response, I guess. But anyways, so probably when we are talking about the filtering object, a filtering is nothing but we are going to put a criteria and we want to get the values out of it. How do we do this? Check this out. I want to go back again and say print all the values of salaries. So you know that df of salary is going to give me all values of salary column. Now let's run this example and see whether it is true. This is true. Indeed, I can see the list of salary values. Probably, am I calling the name only for function 2? Okay, let me comment that function 2 and focus only on function 3. You see here, I'm getting all the values here from that function 3, which is kind of giving me all the values here from that salary column. Absolutely right. So I call that function, and here I'm getting all the values here. Don't need them right now. We'll need them later. So what I'm saying here is, instead of looking at all the salaries, how do I filter them out? Okay, how do I filter them then? To filter them, let me think about a criteria. I want to look at only those salaries which are greater than, let's say, 50,000. Again, because of the pandemic, I want to fire those employees who are getting the values, who are getting the salaries greater than 50,000. So I want to find out their information. How do we do this? To do this, probably I have to understand that when I say df of salary, this is going to give me a series object. Please understand that this is going to give me a series object. And because it is a series object, you know what? This series object is again can be filtered out by using the same example I showed you earlier. If you look at the page 1 here, you can understand somewhere here. You can understand how to get a series object filtered out. Now, if you are filtering out the series object, this is the way you can do it. Probably you can understand that in this example, we have filtered a series based on this criteria. S1 is greater than 30, you know. So S1 is greater than 30 is the condition where we are trying to get all the values which are greater than 30. So probably if I want to do it again, and here I want to do it for a salary. So how do we do that? So salary is kind of giving me an entire series. And if I want to simply, just get all the values here, put one more column, put one more bracket here and say, I want to get the salaries out of, salaries greater than 50,000. Let us first do this. Let us see what do we get. And then we will put that in a salary and we'll try to get the values. See what we can get out of this. I'm trying to find out the salary values greater than 50,000. Let's see what does it give me back. Can you see that? It is exactly similar like what we were getting earlier. Oh, all the values are greater than 50,000. My God, this company is paying really high. Let's try 60,000. Oh my God, all of them are 60,000. Are you kidding me? Oh, 6,000. That's why I was wondering. 60,000. Yeah, there are few records which are below 60,000 and there are few records which are greater than 50,000. So now it is giving me a kind of a condition where we are trying to understand that these values are greater than 60,000. Fine, I'm okay with it. But where are the values? I'm not getting the values. All I'm getting here is true, false, true, false, true, false, true, false. So how do I get all the values then? I mean, I understood that this is a kind of, say, a filtering object and a filtering example. And a filtering example is doing its job. It is telling me that the first value is not greater than 60,000, not greater than 60,000. This is greater than 60,000, so on and so forth. But I'm not interested in that true, false, true, false. I'm interested more into the values. So how do I get them? To get them, simply say print and say df of salary greater than 60,000. So probably when I say run, you will get all the values. I mean, all the values where the salary is greater than 60,000. Can you see that? When I say df of this one, it is giving me the entire data frame back, but not all the values. Do you see something? 0, 1, 2, 3, 4, 5 missing. They are missing here. We are starting with 6. What could be the reason? The reason behind this is, let me just enable the one above it, and you will see the reason why we are not getting these records. Can you see the reason? Here we are having the salary 60,550. Here we are having salaries less than 60,000, and here, because we are looking for the salaries greater than 60,000, we are getting directly the sixth record. The first 5 records are kind of missing. They are missing because the salary is not matching. Not only that, do you see that the 7th record is missing, 11, 12, 13 record is missing. Why are they missing? They are missing because the value or the salary values on those particular rows are less than 60,000. This is an example where we are trying to perform a SQL query which look like this. Select star from salary data. I'm sorry, salary data where the salary, excuse me, where the salary is greater than 60,000, you know. So that's again where clause we are using here. So this is going to give me all the values which are kind of having salary values greater than 60,000. I hope you can understand. Are you getting this, guys? Hello, are you getting this, all of you? What we are doing here, we are trying to find out all the rows where the condition is matching, where the criteria is matching. The criteria here is df of salary is greater than 60,000. Okay, let's try one more time. Let's see how many records are there where we can have the years of experience above 2.5. So I want to find out how many employees are there who are a little bit, little bit experienced. So I'll consider 1.0, 1.1, 1.2 up to 2.5 as a kind of junior level developers. I want to find out the senior level developers. How do I do that? To do this, all I'm going to say here is df of years of experience, which is greater than, for me, let's say 3 and above will be the little bit senior experienced or senior developers. So if I want to find it out, you see, I'm getting only those records where the years of experience is above 3. And you see that that's very true because first few records are having the salary, having the years of experience less than 3. And that's the reason why I'm getting directly the 6th record again. So probably when you're thinking about something like getting the filtering done, this is the way you can do it. Probably if I just want to convert that into SQL, then probably I can just say that select star from salary data where years of experience is kind of greater than or equals to 3. As simple as that. So this is the way we are kind of comparing pandas with SQL, and this could have been done in Excel as well. So probably you can just go back here and maybe you can put the filtering and all of this job, and you know how to do that in Excel. So probably I would have done that in Excel. I'm doing it here in Python by just writing a couple of lines of code. Very simple, very, very simple. Can we, if you want the records range between 60,000 and 50,000, how can we do it? Of course, we are adding only one condition here. Just hold on for some time. I'll show you a couple of more examples where we are having combination of criteria or combination of these conditions there. Okay, just hold on for that, Adish and Tanya. You will both get how do we have multiple options here. Okay. Share the file once more, not a big deal. Just give me a sec. I'll do it one more time. Those who didn't get that, who's that? Just a sec. Tanya, you want me to do it again? Sorry, who's that? Vishal. Okay, I'm going to put that salary data CSV file directly one more time on your chat. Just go there, get that, grab that, and probably you will be able to see it, how it can be done. Okay. Okay, so now I want to perform an operation here. Again, one more time. This time I want to perform an operation based on the similar requirement, but it's not like I want to go for the entire row. I think things are looking great, but you know what? Should I or should I not? Okay, let's do it later. I was thinking about to change one more CSV file, but better We'll first finish it off with this example, and then we'll go for one more CSV file. In this case, I want to go for, again, a similar condition. It's like I want to find out the salary for all the employees who are who are having or who are getting the salary greater than 50,000, but I'm looking only for salary column, not for the years of experience. Now, probably this would have given me last time the number of years of experience, at the same time the salary values. Fine, it's giving me both of them, but it's not like I'm looking for I'm looking for both years of experience and salary. I'm looking only for the salary. Or if I'm looking for only the years of experience, both of them will give you the similar information based on the code you are writing here. So basically what I'm trying to say here is this is returning one more data frame. And if it is a data frame, I can I can simply go back here and decide which of the columns I'm going to use here. So probably I can say this is going to be the years of experience. If I'm looking for, that is going to give me all the years of experience where the salary value is greater than 60,000. So what I did here was I was getting all the values, but all the values where the salary is greater than 60,000, but I was getting both. I was getting years of experience and the salary. But here, I'm not interested in the salary. I'm interested in only years of experience. And this is the way we can do it. So probably whenever you are thinking about doing this here, probably you can get only the salary values, not a kind of, salary and years of experience. So it's not giving you a data frame. It's giving you a series object one more time. So you are trying to get only one column out of it where the salary is greater than 60,000. Let's do it again very quickly. If I just want to come back here and say, hey, I want to get the salary of those people who are having, let's say, years of experience greater than five. So probably if I want to do it, see how it can be done. If I go for years of experience is greater than or equals to 5, probably I'll get both in a sense. I'll get the years of experience and I'll get the salary. I know that years of experience is greater than 5. I don't care about what exactly years of experience these people are having. I'm just looking for the salary so that I can filter the salary and I can fire those people, as simple as that. So how do I do this? To do this, not interested in the years of experience, I'm just going to go back here and just look at the salary so that, it will be easy for me to understand how much I'm giving those people who are having more than 5 years of experience. You see, this is the way I'm getting only the salary out of it, not the years of experience along with it. So select salary from salary data where the years of experience is greater than 5 or greater than or equals to 5. That means this is the way we are going to filter out the data based on the years of experience, and on top of it, we'll just get only the salary value there. That's it. This is the way we can do that. It's very, very, very simple. So now if you pay a little bit closer attention, you can see that this is the way we are trying to understand that, this is the years of experience. Based on that, we are filtering the records, and not only filtering the records, we are kind of selecting the records based on our criteria. Right now, there are only 2 columns. That's the reason we are juggling between them. But when you are having multiple columns, this information is going to be very, very, very useful. I'll show you a couple of more examples in a minute with another type of CSV file. Okay. Can we get the position of metadata? I'm not sure what you mean by position here. Position is nothing but the index. Can you see that here? This is nothing but the index value. So this is nothing but the positions you're looking for. And who's that? Maybe Senthil, if you're looking for, without mentioning the column names. No, here you have to use column names. There is no other option. If you want to go for, using the index positions like 0, 1, 2, 3, 4, there is another way. There is a better way, and the better way here is called as a ith location or something called as a ilog. So just wait for a minute, Senthil, you will get that answer there. Okay. Okay. So probably when we are talking about something like this, I can understand that this is the way we are getting the information based on some criteria, some conditions. That's okay. Now let's do one thing. Should I or should I not? Let's do it here. Now, sometimes it is required. Let's say I'm talking about the same data in Excel sheet. Now, this is the data we are having in Excel sheet. And imagine that maybe we are having the years of experience, we are having the salary. Maybe just imagine there is no pandemic and the Diwali is coming. I want to give these people a bonus. How do I do that? I'm thinking about give them a 10% of bonus. So to give the 10% of bonus, I need to calculate a bonus column. I need to create a new bonus column. To create a new bonus column, I can go in the Excel, create a new bonus column and create a formula. The formula could be this into, let's say 0.10, 0.1, whatever it is. So the bonus for this person is like 3,934. I can simply copy this and just drag and drop, and you see that now it is giving me the bonus for every single row. See, this is how we could have done that in Excel sheet. We could have written a formula. Using the formula, we could have added a new column, and this newly added column would have given us the bonus that I have to pay to those employees. Very, very, very simple. It's even simpler in Python. I'll show you that here now. Say I want to get the bonus, let's say 10% bonus for every single employee in case of this. So how do I do this? Okay, let's see how do I do that. This operation here is called as adding a column. Adding a column. This is required in data processing job where you want to, let's say, combine some data, or you want to add a new column based on existing data. You want to, let's say, maybe combine, or maybe you can say change the data type of existing data and create a new column. So adding a column, creating a new column is very much required in the data processing job. So how do we do this? It's really simple. All you are going to say here is a df of, see, I know how many columns are there. So probably even before I add a new column, I just want to see how many columns are there. How do I do that? See, this can be done by using print df of columns. Df of not columns, df of info. Df of info will tell me like how many columns are there. And probably I didn't call that function. This is function 4. And probably this is the one which is telling me that there are 2 columns, years of experience and the salary. I think there is a columns, not a method, but there is a property as well, which is not giving you here, but I'm damn sure about it. It was there and it should be there still. Yeah, it should be there and it is there. Sometimes you will not get the intelligence there, but nothing to be worried about. I know it's there. So this is the columns, and this columns is telling me there are 2 columns right now. Column 1 is years of experience. Column 2 is nothing but salary. Okay. So this is a kind of number of columns we are having here. Fine, I'm okay with that. But now I want to add a new column. How do I add a new column? Very simple. All we are going to say here is there is no column called as a bonus, but now I want to add one. So how do I do this? Remember last time in NumPy we talked about something called as a broadcast operators. So when I say bonus is equals to 0, it is going to create a new column. This is the broadcast operator. Broadcast means it is going to create a new column bonus, and it is going to add a 0 in every single row. And if you don't believe me, let me just go back here. I'm not going to show you all the rows, but can you see that if I'm looking at the head of 4, or let's say head of say 5 or head of 6, whatever, you can see that first 5 rows is telling you the bonus is set to 0. This is a broadcast operator. Now, actually speaking, I don't want to set them to 0 because I do want to give them some bonus. So how do I do that? To do this, probably I'm going to come back here and say whatever is the value you are having in the salary column into, I'll say let's give them 10% of bonus. So probably now if I go back here, you see I'm getting exactly same data as I was getting in that Excel sheet. You see 3934.3, 3934.3. Of course it is. It's just multiplication of 0.10 into the existing column of salary. As simple as that. I don't know whether you are getting this or not, but this is so simple now. I can add any number of columns there. So this is the way we can do it. And if you just print that number of columns one more time, you will understand. Earlier we were having only 2 columns, but now we have the 3rd column added called as a bonus. We added that column on the fly just by using the existing column. We are kind of creating a new column there, and this is required. Many a times it is required. So this is the way you can do it. Okay. Okay, what are you saying, Utpal? Can we have change the position of column? Yes, we can. Wait a second, I'll talk about it. Avlash, will it be also added in CSV? Of course not. Whenever you are performing these operations, adding a column, removing a column, maybe changing the column values and so on and so forth, that will be not stored in the CSV file because we already have read the data in memory, and we are playing with the data which is there in the memory, not in the CSV file, So the data will be modified in the memory, but not in the CSV file. Is it possible for us to do it again? I mean, just for us possible to create a new CSV file out of it? Yes, it is. You can say I'm sorry, not PD. It's a df dot write. What the hell? PD dot write. Sorry, my bad. PD dot write. What the hell? PD dot read a CSV, write CSV. There is an option. What was that? I forgot that. Save, not this one. Oh, what the hell? I forgot that. Was it a read or was it write? I think it was a write operation. I hope it is. Not able to recall it right now. But df dot. Let's see. There is an option for this. I know for sure. Just give me a sec. Not many a times we need to write it, but there is a function. I'm sure about it. I just need to look at it. 2222, yes, to CSV. That's correct. So to CSV, for example, let's try that. I hope that's the file name I'm going to try here. Maybe I'll say this is the new data.csv. Now, when you are trying to do this to CSV, maybe this is where we are saying write the file, write the changes to the new CSV file. So probably Lomash and even Abhilash, if you are trying to put that into a new CSV file, this is how we can do it. And see, it's not giving me anything back here, but if you look at your current folder, you see that we have created a new CSV file. And guess what? If I open this new CSV file right here, you will see that now we are having the third column inside it. So if you just open that right here in your Excel, you will see that in that Excel, you have created a new column here. See, this was my existing, and this is now my newly edited CSV file. So whatever operations you are performing on CSV file, all of them will be performed with in-memory data, but there is an option. You can save the data by using this to CSV, and this will solve your problem. Abhilash, I think you are getting it. Lomash, how to write the result of some computational operation in CSV? You got the answer here. Preeti, how can we limit the decimal places to 2 or 3? You can't right now here because that is a kind of a float object. You can't. This is just the formatting part, not the actual part. And it's okay just to have it here. While printing it out, you can decide how you can skip it. But right now, let's put whatever the value we are getting out of that bonus, we will put this right like this one. Tanya, what you're saying, if you are having a salary column in the dollars, then containing dollar is a symbol. How can we remove dollar and blah, blah, blah. Tanya, I think what you're talking about is like processing the data. I mean, of course, I can show you right now, but there are n number of such examples. I can't answer all of them in a short time. This is a kind of introduction to this one. Okay, there is one more. I mean, not for you at least this at this point, but when we go to ML, there we are going to talk about a lot of other things like how to remove the NA values, how to add the columns, how to merge them, how to perform all these operations there. This is a quick introduction of pandas data frame. It's not the complete data frame here, complete pandas, because if I want to just talk about the pandas, it will take another maybe at least 4 to 5 sessions just to talk about the pandas. There are many operations out there. Okay, so probably this is just a kind of we are restricting ourselves just to look at a kind of introduction to pandas. So those who want to learn more about the pandas, they can think about this as a foundational, and then on top of it, they can learn on their own. Okay. Senthil, merging file can be also done. Yes, not only merging file is also possible, merging different columns together also possible, creating different columns out of merged column is also possible. Many things which are possible here. If you use existing CSV file, it will override. Yes, of course. So when you say something like the salary data / salary data like this, then probably you can understand it is going to overwrite your existing data, salary.csv. So salary data.csv. Now, when you do it, it is going to override your existing data. So probably, who's that? Yes, Sripati, if you want to update your existing one, you can use the same file and it is going to do the job. Okay. Rohit, are you planning for ML? We'll talk about that later. Lomash, can we use a text file in the pandas? Yes, you can, but you will not be able to get the data out of it. I mean, not the data like in terms of data frame. Probably not here, but there in ML, there is a part called as NLP, where we'll talk about natural language processing. There we have to read the textual file and we'll have to perform the searching operation or maybe filtering operation based on the different words out there. So there, what you are looking for is possible by using, again, pandas. And pandas can also do it, and there are different options, or there are different packages which will be able to give you what you're looking for. Akanksha, when we are having a machine learning, we'll talk about that. It's not in the schedule, we'll talk about it. Okay. So first, let's finish the technicality of it. We'll talk about the remaining part later. Anyway, so right now, if you pay attention to this one, we are trying to get the data, we are trying to add the column. But as I said earlier, it is possible that we need some column, or we need to remove some columns from the existing CSV file. Let's look at one of the other CSV file. So probably today's what? Tuesday, right? Let's go for wine.csv file. I mean, I know it's not Friday, but still, I want to go for that wine. So there are many columns out there. There are almost like 14 columns there. And this is again one of the examples in machine learning where we can predict the customer segment based on the alcohol he is having and what are the different percentages of components in that alcohol. So that's a CSV file I'm going to read here. I'll put that right here on your chat as well. So it will be easy for you to do it along with me. And probably we'll see how we can perform an operation of removing the columns. There are 14 columns here. And after inspection and after looking at the data, I would notice that there are maybe only a couple of columns are required. Rest of the columns, I don't need them. So if I don't need them, I can delete them one by one. That's the simplest example I'm going to try here. Watch this. Let me copy this in our directory right now. That's wine.csv. Coming back here in our code, and let's do it here. So this is function fine. There is no point deleting that salary and years of experience. There's hardly 2 of them. So it's okay. We can use the same function again, df.readCSV, and we can say, hey, I need to read that wine.csv data. First, I want to quickly look at what type of data we are having right now. Just go back here and say df.head. Head will tell me the data, first couple of records. So it will give me a quick idea about it. Info will tell me what are the different columns, what are the different type of data we are having there, and blah, 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 like this. Along with this, if we are interested in the statistical information, I'm going to go back to the describe method, which is very important later. But right now, I'm just going to call just to see what exactly the data we are going to deal with. So when I say run, probably it is telling me that there are many columns. You can see this is a kind of a head, which is going to tell me the first 5 records. Fine. It seems like there are almost 14 records, or sorry, 14 columns. And you see that almost all of the columns are either float or integers. In a sense, that's an integer, that's a numeric data we are talking about. Probably if I look at the describe, describe is giving me more statistical information. There is a column called as alcohol where there are 178 records. There is a mean of 13% or 13 point something, or the minimum value is 11, standard deviation is 0.81, and so on and so forth. Don't care about those values right now, but this is the kind of statistical information I was getting here. Okay, now what happens here is, like, when I'm inspecting the data, seems like there are 14 columns. Actually, I don't need all of them right now. So probably what I'm thinking here is to delete few columns. Maybe if I just open that CSV file and say, I don't need, let's say, alcohol, malic acid, and ash. So I want to delete those columns. How do I do that? See, we are having 14 columns. So I'm going to just put everything in comment for now, and we'll see how many columns are there. df.columns, and probably if I look at the columns list, you will see that there are almost 14 columns there. So what I'm going to do here is I'm going to drop a column. Maybe you can drop multiple columns as well. So here I want to drop one column. How to drop a column? There are 2 ways to do that. There is a function called as a del. You can call that del function, and you can say, hey, I want to delete a kind of, not a function, it's an operator actually. I want to delete a kind of a df of, what's the name? Alcohol. So probably I'm going to say that delete column alcohol. So drop a column or delete a column, whatever you say. Let me see if I can delete that column. And if I try to print this df of columns again, will it be same or will it be different? You see that last time I was having a column called as alcohol, which was the first column in this list. And probably you see that it's missing right now. It's missing right now because we just have deleted that. As simple as that. What if I want to delete multiple columns? Like I want to delete the malic acid as well. Not a big deal. Just go back here and say del df of malic acid. And you would notice that malic acid is also gone. You see, it starts from ash. So basically alcohol and malic acid, both of them are gone. So probably this is the way you can drop multiple columns. I mean, drop a column at a time to have the deletion of multiple columns in one single statement like this. Actually speaking, I want to delete 4 more columns. You know what? I want to delete the ash, delete ash alkalinity, magnesium, and total phenols. I want to delete 4 columns like this. But if I want to delete those 4 columns, probably you can notice it here. I have to literally write 4 different statements to do that. Isn't there any way I can delete multiple columns together? Of course, yes. So you can say drop columns. Instead of dropping a single column, you can easily drop multiple columns as well. How do I do this? To do this, I'm going to say df.drop. So df.drop, and this is the list of columns I want to drop. This is the first one, second one, third one, fourth one. And then, very important, that's where the access comes into picture. If you look at this diagram here, I mentioned rows are represented as access 0 and columns are represented as access 1. To be precise, when I want to delete these columns are represented as access 1. So I have to say which part or which access you want to delete these columns from. If I do not pass anything, by default, it will try to delete rows which are having these values, ash and ash alkalinity and so on and so forth. To be very precise, we don't have any rows there with these values. We are having only columns. So what do I want to do here? To drop a column or to drop multiple columns, we have to come back here and say access is equals to 1. Access equals to 1 is kind of important here. And that's the reason why I already mentioned access 1 represents column and access 0 represents a row. So precisely, again, this is the way you can do it. Check this out. I'm thinking about to get the columns here first, dropping 2 columns, alcoholic and malic acid, and then I'm trying to print it there. But before printing it out, I'm just dropping 4 columns out of it, So it should give me, let's say 4 less columns in the next part right here, But this is not going to happen. You see that the ash alkalinity, magnesium, and total phenols, all of them are still there. They are still there because, understand this, because the drop function does not drop these columns from the original DF. The original DF will remain as it is. Instead, it drops this column and it gives you a new data frame out of it. If you really want to save the changes, then probably we'll have to say df equals to df dot drop and do something like this. Probably whenever you are talking about something like a drop operation, or there are a few more operations out there which are not going to modify your existing data. Del, on the other hand, is deleting that column directly from df. Drop is not going to delete it from the original data frame. It deletes it and it creates a new data frame copy and then it deletes it from there and it returns that copy as it is. So if you really want to persist that change, you'll have to say df equals to df.drop. If you do it, probably you can see that now those 4 columns are gone. So ash alkalinity, magnesium, and the total phenols, all of them are gone just because I tried to save those changes back to my original DF. Of course, you can create a new DF out of it as well. So DF, underscore new. This would have created a new DF here. So DF underscore new dot columns. So this is where we can see the original DF columns. They are still there. And this is where DF new column, we see that these 4 columns are now not available in the newly created DF here. So remember, whenever you are performing an operation like a DF does not modify your original data set. Instead, it removes the columns and it returns that to the new data frame like this. So this is the way we can do it. I hope you are getting it. So whenever you are performing these kind of operations, you can always remember to save that or to get the DF out of it and either set it with the original DF, or if you want, you can create a new DF out of it. That's the reason why you are not getting the ash and other columns removed from your original data frame last time. So this is the way you can do that. As simple as that. I hope you are getting it. I hope. Okay. That's fine. So if you are getting all this information here, that simply means we are kind of able to do it with the index proper. We are able to perform the indexing, or we are also able to perform the filtering part. Now, as I mentioned earlier, I'm going to show you a couple of other examples as well based on the position. Someone was asking that question, like, how can I go for using index as a integer position, not as a string position? Let's see what I'm talking about here. So this is going to be page 4. I'm sorry, again going to read that salary data. Salary is a pretty small data, that's why I'm going to do it in that way. You can use it anything, it doesn't matter. So probably here I want to read that salary data one more time. Now this time I want to get all the values again, but this time I'm not going to use the same format which I used earlier. Last time, if you can recall, I said give me the salary record, and this would have given me all the salaries here. Sorry, function one, all the salaries here. I mean, it's giving me the entire column salary with all the rows there. And if you are looking for only one of them, let's say the 0th row, for example, this is the way I would have done that. Now, using this, there is no harm in it. I mean, it still works, but you know what? You have to literally write the column name every single time. And you know, sometimes we make mistakes, and because of that, your application might crash. So isn't there any better way to get the things done pretty much easily? Of course, yes. So if you want to do that, instead of doing this one, I'm going to use the another strategy, and this strategy is called as ith location. So basically what I'm trying to say here is df.iloc. iloc stands for ith location. So basically when I say ith location, before that quickly, I just want to print the where are you head here. So at least it will give me a kind of idea what I'm looking for. So this is the data. I want to get the data. Let's say salary equals to 39, whatever, 343. So if I want to get this one, I used this syntax, df of salary of 0. And if I just run this, you will see I'm getting the same salary which I talked about here, 0, 0. So instead of going for the salary of 0, I can go for a better option. So here I can go for an option like a 0, 0. 0, 0 means it's going to give me the value at 0, 0, 0, 0, 0 means it's a 0th column and 0th row. Sorry, I mean, I went for 1.1. Actually, it is a 0, 0. I should have gone for salary. So I can go for, hey, just give me for a 0th row and the first column, not the 0th column, and then you will get 39, 433. You see here, iloc gives you the value based on the row position and the column position, and both of them are integer values. I hope who was asking that question last time? I said just wait and you will get the answer. I don't remember, but someone was asking the question like, how can I do it with the index metadata? And I said this is the way you can do it. It's called as iloc. Iloc is the way we can get the values based on index positions, which are numbers, not the values, not the actual string values like this. See, both of them are giving me the same result, but having this in place will give me a kind of a flexibility to run a for loop on it, or give a flexibility to go for a kind of, you know, slicing behavior on the column values. That's the reason why iloc is going to be important for you. So salary of 0 and iloc of 0, 1 is going to give me the exact same record. Let's try one more time. I'm going to get the value like 2.0. How do I do that? So probably you can understand. If I want to get this one, let's try both of them again. Sorry, let's try both of them again. If I want to get this particular record, then it's not the salary. This should be years of experience like this. And the row position is 3. So this is how we can do that. Probably if I just go back here, I'll get the value 2.0, which I was looking for. Exactly, 2.0. Now, how do I get it from iloc? I think it's very simple. From iloc position, third row and the 0th column is what I'm looking for. And guess what? You see, I got the records here. That's it. That's it. This is the way we can do that. The data frame is 2-dimensional array only. Yes, it is. Can we have more dimensions in it? No, I mean, you can, but it's of no use. More or less, Rohit, when we are using pandas, we want to read the CSV files into it, and the CSV files always are number of rows versus number of columns, means always a 2-dimensional array. That's the reason why we are dealing with only 2-dimensional data here. Okay, so now you understand like how to get the data based on the iloc position. You know, iloc means ith location, and ith location is where we are going to pass two values, 0 and 1, where 0 is the row position and 1 is the column position. So that's the way we can do it. Guys, are you getting the difference between having the line number 20, line number 12 and line number 13 in place? Both of them are giving you the same result, but one is giving you the result based on the column name, the other one is giving the result based on the index position, which is an integer position. And that is the reason why we are using it here. Let's see here, what's an advantage of this? Maybe not with this example you will get any advantage of it, but definitely with that wine data, you definitely will see how better this example or how better that method is instead of going for the string column name. You see, I'm having a wine data here. For now, I'll just go for df of head just to understand how many columns are there, or I can just go back and use the columns for columns attribute in order to get all the columns. This is the data which is having 14 columns in it. I can see that, and right now I'm getting only 5 rows. Fine, I'm okay with it. Now I'm looking for, let's say, alcohol, malic acid, and ash. These 3 columns. Okay, how do I do that? Now to get these 3 columns, probably you can come back here and say df of, maybe you can say this is alcohol, whatever it is, right here. Maybe the second one is malic acid somewhere here, and the third one is again an ash. That's it. So this is the way we can get only 3 columns out of it. So we are having 14 columns. Out of them we have just received only 3 columns. When I say 3 columns, I have got all the rows within the 3 columns. You see, this can be written in a better way by using df of, remember just now I said that df.ilog. Now precisely it's like I want to go for 0, 1, and 2, which means I want to go from 0 to 2. So how do I do this? Remember, we are having a slicing operation, or a slicing part already covered last time. So I'm going to start from 0, I'm going to start from 0 colon, I want to go to 3. 3 means 3 minus 1, that's 2. This is about the rows. Actually speaking, sorry, my bad. This is about the rows. Rows means I want to get all the rows. How do I get all the rows? I should say 0 up to a length of number of columns. You know what? I'm going to say only colon here. I hope you can understand. If I say only colon, that means this, the left hand side will start from 0 and the right hand side will go up to the last part of it. That's it. But don't stop here, because this is something regarding the row. We want to go for only 3 columns, first 3 columns, which means I can say that 0 colon 3. So if I just go and say run, probably you can understand this is going me exact same records. That's even better to read, even better to write. You see, I'm getting the same result here: alcohol, malic acid, and ash. You know what? You don't even have to specify the 0. I hope you know that. If you do not specify 0, you can directly start with 0 just by saying colon 3. That's it. So probably this is the way you can do that. Probably, no, I want to get the first 10 rows, and then in that first 10 rows, I'm going to go for first 3 columns. How do I do this? Very simple. Again, all we have to say first 10 rows means I'll have to go from 0 to 9. I'm sorry, 0 to 10. That's it. I don't even have to specify 0 here, because you know that by default it will start 0 and 0 in both the conditions. And that's the reason, you see, I'm getting first 10 records and only first 3 columns out of it. Very powerful. If you know what does this mean, you can easily use that ilog to perform any operation to get any type of data. So the first part before comma is representing the row position, and the second part after the comma is representing the column position. Now based on your requirement, you can do it here. So which row or how many rows and how many columns you want to go for, just use that index slicing part here, and then you will be able to get whatever you are looking for. Very, very, very simple. It's a combination of filtering plus the slicing. Everything is there in one single part. That's ilog. Ilog is very famous when you are in pandas. This will give you a chance to not only get the data, but also this will give you a chance to just get the data based on certain conditions. Can we modify the data that we have got from ilog? No, you can't modify it. If you want to modify it, then you will have to create a separate df out of it. And most of the times, the operations which you are performing here, they are performed for analyzing the data, not modification of the data. So Shrikant, look at the big picture. The big picture is, later on, I want to use this data for, let's say, machine learning or for maybe some other purpose. But before that, I want to process the data. I want to analyze the data. I want to understand what the data looks like, what are the different things there, what are the different columns there, what are the different data types of those columns, are there any columns having missing values, and so on and so forth. So whenever you are doing something called as analysis, most of the times you don't want to modify the data. If you want, you still can modify the data, but data will not be persisted in the same data frame. You will have to create a separate data frame out of it. Okay. So probably you see here the data is retrieved very well, but now I just want to go for the filtering condition one more time. Do you remember I talked about getting maybe a data based on certain conditions? I'm going to do that on this salary example one more time because we already have seen that there. So actually speaking, I want to get all the salary values, all the records where the salary is greater than 60,000, for example. How do I do that? To do this, I'm going to say here a df of a salary, df of salary. This is what we have seen last time, which is greater than 5,000, 50,000, 60,000, whatever, 60,000. So probably it is going to give me the record. What is it? Here it is. So df of, my God, this is the one, sorry, my bad. And if I look at this one, you can see that it is giving me all the records for salaries equals to salaries greater than 60,000. We already have done that last time. Now I want to transform this into the ith location one. So how do I do this using ith location? You can say df.iloc. I want to get all the rows, all the columns, and then I want to go for, let's say, df of salary or df dot salary. You can use anything there. You can say df of salary or df dot salary, which is greater than 60,000. So when I say run, you see I'm getting exactly same result here. Now, if you can recall the last example I said somewhere here, I said I'll show you that by using ith location or ith. Where are you? Here it is. Huh? So I was saying like this one. So if I want to go for this example again, this is what I'm looking for, you know, just a sec. This is what I'm looking for. Select years of experience. Not that. Is that the one? Okay, fine. So years of experience and salary. This time I'm just going to go with years of experience so that you will see how we can use that iloc and how we can get the only first column out of it. Where the salary data is greater than salary data, what the hell, from salary data, where, what was I looking for? Let's say salary, say salary greater than 60,000. Okay. So how do I do this? Here I was getting all the columns like years of experience and the salary. If I just run this again, you see I'm getting both the columns, years of experience and the salary. Now you can understand it is giving me both the columns because I'm having colon here on the second part. If I'm looking for only years of experience, I'll say 0, and then it is going to give me only years of experience here. You see 3.0, 3.2, 3.9, so on and so forth. So I'm getting only the years of experience here based on salary is greater than 60,000. So this is not only filtering, this is also selecting the number of columns you are looking for. So this is a combination of both of them. It's pretty simple if you are using the iloc or iloc position or iloc method. It's not a method actually, it's the kind of attribute we are using, which is going to deal with the df based on the numeric positions of rows and columns. That's an advantage of it. And that's the reason why iloc is kind of required. Based on this, whenever you are thinking about performing any operations, just use the same attributes or same methods which we have seen earlier and try to perform them. I bet you will be able to do whatever you are looking for. Now, I think I'm not going to go too far from it because there are many different things, as I mentioned earlier. If I want to talk about them, it will take another couple of sessions just to talk about the pandas. I think that will give you enough understanding of how the pandas objects are created in both 1-dimension and 2-dimension arrays, how we can perform different operations. What the hell? How do we perform the different operations like indexing, filtering, and so on and so forth on both series and data frame. And you can understand when to use data frame, how to use that CSV file, load the data into data frame, and how to process the data. And once you are done, you can always save the changes back to a CSV file, back to a normal CSV file or text CSV file here. Okay, so have you got a kind of introduction to data frame? Are you okay with that, guys? How to update the values, just modify the values, whatever you are looking for. But again, as I said, this is not very important and this is not very required, you know. Yes, yes, Vijay, please tell me. Have anything? Okay, fine, no problem. So probably this is the way we are kind of doing the job. Hopefully, probably you are getting the data frame. If you are getting the data frame, then probably you can continue using data frame, and possibly you can filter out all the you can process all the data you are looking for. Okay, fine. So today we are just processing the records. We have just analyzed them, but analysis would have given me better analysis would have given me some better understanding if I would have gone for a visual representation of a data. And when I go for visual representation of a data, probably I'm thinking about to put this data into a kind of a chart, you know, chart, or maybe a kind of, let's say a different type of charts like a bar chart, scatter plot, pie chart, and so on and so forth. So probably the very next example, we are going to do this exercise quickly one more time tomorrow. And in the next example, we'll try to put that data into number of different charts possible by using a library called as matplotlib. Okay, so that's a matplotlib example we are going to see tomorrow, where we are going to put the data into number of charts. Okay, no problem. Yes, but practice must be there will be, I mean, practice should be there, practice must be there, otherwise you'll forget that. I understand that your concern, Adesh. Lomash, a good reference of source to learn more operations with pandas. Just wait for a couple of more days. In the next week, I'm going to put one, I'm working on it right now, so I'm going to put one video playlist on YouTube. You will see that I'll share that with you on the next week. So probably you'll be able to see not only pandas. I'm preparing one more series for matplotlib as well. Tomorrow I'm going to give you a quick overview of matplotlib, but in the next week I'll share 2 links with you where you can go to the YouTube channel and then you can watch all the videos where I'm explaining how to do these things in little bit in a depth fashion. Okay, so I'll share that in the next week with you. Shrikant gave you an example of modifying the values. Sure, no problem. Tomorrow, before talking about putting the data into the matplotlib, we have to run a exercise quickly. There I'll show an example of it. Okay, fine. I think it's better we can call it a day right now, and probably yes, Priti, image processing, we are going to take a quick look at OpenCV as well. Of course, yes, I mentioned that earlier. There is a session which we are going to talk about image processing. Probably tomorrow we'll talk about matplotlib and we'll start talking about something called as beautiful soup and selenium. Day after tomorrow, on Thursday, we'll talk about something like a Flask, where you are going to get a REST implementation by using Python. And 2 days after tomorrow, that's on Friday, the last day we are going to celebrate with the image processing, where you will see tremendous kind of operations performed on an image, like what a Photoshop can do. We are going to do that right here using OpenCV. And believe me, it's very simple. Anyways, we'll talk about that later, one by one. Yeah, GUI, no, we are not going to talk about that, Utpal, because there are a few limitations on that. So that's the reason why we have dropped it. That's the reason why we are going for the other options. Okay. Yep, no problem. Okay, so I think it's better we can call it a day. We'll continue exploring the next package tomorrow. By the time, again, I'll see you tomorrow exactly at 8 o'clock. And by the time, please have a practice. Just go through these examples one more time and just wait for next week. You are going to get a new playlist where you can have all the in-depth sessions for pandas and for matplotlib. Okay, till then, it's better. I'll say just goodbye to you. Have a very great day ahead, and we'll see you tomorrow exactly at 8 o'clock. Bye-bye. Have a nice day, of course. True. That's required.